artificial intelligence.
What might be the perfect programming language look like in the era of AI? That is a question that is being tackled by our next speaker. He is the solutions architect at Realty Calendar. So please put your hands together and make a lot of noise for Mr. Vlad Dyanchenko.
Yeah, microphone is on. Yeah, at first, thank you everyone for coming to this talk, to this conference. And to be honest, I'm really happy to visit Nepal because of Doctor Strange movie and all these camera touch vibes. But in general, I really like to travel, but the problem is that I don't know how to rest. So in case I take vacation, I will do some open source, I will do some personal projects, I don't know, just sort through my bookmarks, but I want rest. So it's a great opportunity to be able to travel while giving people some useful ideas or thoughts, let's say. So yeah, also want to thank our organizers because I just want to finish my talk and sit in these super comfortable chairs and speak to other speakers. So let's clap for them. Yes, it will be another talk on AI, but we are at AI conference, so let's go. Just a bit about myself. I like this meme. So it was me preparing this talk. So I work as a solution architect at Realty Calendar. I still write code, not as much as I want, to be honest, but mostly right now I consult teams on some agent-friendly architectures, developer experience, and so on. But in my experience, I've built different system XROs like Ruby, Rust, Golang, a bit of TypeScript, a bit of Python, but still had some experience, let's say. And I still do some side projects like Index Machine, ShareSpeak, so because I still like to learn new things, to launch new things from scratch, like that involve some LLM usage, rack systems, I don't know, like N8N pipelines and so on. So in case you want to talk to me, like chit-chat, consultancy, I don't know, just to discuss something, I'm at your disposal, scan this QR code. So we all heard about AI, let's say, gloomers and doomers. And in 3 years, there will be no developers we will have 10x more productivity, I don't know, so on, like programmers becoming, let's say, managers of agents. And we actually can find statements confirming such things, and we can find statements refuting them. So I can personally confirm this meme above. Yeah, just a time for you to analyze it. So I have a lot of fellow colleagues who really don't want to learn anything new. I mean, I can get it. You have wife, you have kids, you have like vacations, hobbies, loans, you have personal life. So after 20 years in profession, the last thing you actually want is to learn something new. You just want things to stay as it was. So, and in reality, we shouldn't be like horseshoe crab, this one. We should be like Tiktaalik. It's the name of this creature, because it was the first creature who was able to breathe both with his lungs and underwater. So we're just moving like Tiktaalik. And today I don't want to look into this glass ball and try to predict something, because we should be like Tiktaalik. We should adapt and evolve. We shouldn't just predict. So let's come back. If we are talking about programming language for the AI era, I don't think we have much choice. Use Python. And the end, thank you for your attention. Actually, I'm open to your questions. Okay. Okay, I'm just joking. So, in the future, AI will be sufficiently smart. So, what language you will use when AI is sufficiently smart? Like anyone from the audience, your ideas. Okay, okay. Okay, good. I suppose English. Probably will use Chinese, but I'm not sure yet. So, but why? Because AI is super good at understanding human language. So, for example, AI is better at writing essays or emails than me. Because in our case, AI is about LLMs, so large language models. And in other words, it's just human language. So sometimes, still, AI is too verbose for programming languages. So, for example, when AI adds a lot of comments, do you feel it? So, like when AI just really like to explain everything is going on, like this one. Produce a sum of two integers and prints it. Super informative, thanks. So, You know, actually, I had an article about this, me being tied to review AI slope. Because when you can say right away that this code is vibe slope, overloaded with comments, excessive, like bloated, repetitive explanations, and so on. So like this one. This is from one of the last test tasks I reviewed, and this strange tradition of LLMs to provide a pass to a file as a comment. Yes, I don't know where am I. Thanks. So, or adding a comment like, this is the idea of your progressive program. Wow, saying scap, I thought it was just random alphanumeric string, so thanks. And still, let's come back. So, why we want all switch to English or natural language? Let's say we take mathematics. Mathematics notation is concise, clear, and logical. But when we try to describe it in human language, it fails because, let's say, if a number is multiplied by itself, blah, 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 very complex. X squared minus 3x plus 2 equals 0. What is x? Nice. But it was an artificial language. I wasn't talking in English. So, same as programming languages. Initially, they were just created like for both humans and machines, just as a language to allocate memory and do some plus and minus operation. I mean, increasing and decreasing. So, just to compare how many tokens we're actually losing when describing it in human language. So, request, contiguous block, blah, blah, blah. Treat the starting address, blah, blah, blah. Stores the value 4, read back, finally release the previous allocated block. Nice. And we are not even talking about some assembly instructions. So, we shouldn't try to overload our bottleneck, our cognitive ability to understand it. So, let's come back to the first part, era of agents. I think everyone in the audience knows what an agent is. Everyone knows, yeah? Good. So, what we need to understand is that actually we are talking about supervised agents. So, Cloud Codes, Codex, Cursor, all of them are supervised processes, supervised agents, because they are meant to be used with technically sophisticated human in the loop. So they require some technical input from us. And when we want to improve agents, we need to improve these 4 parts: models, instruction, tools, and runtime. So actually, we can't do much about model. Yes, we can, but as we, developer community or big companies like Google or Shopify, I don't know. So we are left only with instructions, tools, and runtime. So let's start with instruction. The main goal of the instruction is to guide the LLM behavior. So we utilize system prompts, chat messages, and rule files. And right now, I think we shouldn't focus on chat messages and system prompts because we are not talking about some prompt-driven development or Amazon just presented spec-driven development. Because we should focus instead on rule files. That's what we can do easily. Once again, I suppose everyone knows what agents can be. Am I right? Okay, first rows, oh, okay, good. So what usually happens, people don't know what to put into such files, because the most obvious and common mistake or a solution is to ask AI to analyze your code base, fill it with some related context, let's say architecture, like system design, like some design solutions and so on. But the problem is that people are actually using it as a memory layer. But AgentsMD is not a memory. So while in reality we should pay more to the more attention to the importance of these files. So let's take an example. This is Elixir. Elixir is Phoenix. This is Django or Rails for Elixir language. Do you know about Elixir? Okay, good. So under the hood, it utilizes Erlang. Just an interesting fact. So here's the problem. When we create Phoenix application, it goes right away with AgentsMD file. Problem is how to calculate or find the content for this file. So how we can create AgentsMD for a framework, web framework. And the creator of Phoenix, I don't remember his name to be honest, literally created hundreds of applications using AI, different models, different approaches, and then he manually performed the technical review on them. So for instance, generate Trello clone, generate Twitter clone, generate, I don't know, like Instagram clone, and so on. And after that, he manually indicated errors LLM made. So like, here is suboptimal syntax, here is, we don't utilize new feature from the latest versions, and so on. And then was formed an optimal file where he just fixed all possible LLM errors. So although this optimization may sound like something very simple or like something completely down to earth, but actually it's a very important element of actually applied fine-tuning we can perform easily. So here's the take. That's one of many solutions we can apply to make our language or web framework more AI-friendly, more AI-ready, let's say. We need to focus on filling the gaps between, filling missing data, to fill these gaps between the latest best practices and what LLM actually know or doesn't know. So next block is improving our coding tools. So tools are like read and write files, list directories, some terminal interactions, and mostly importantly, custom tools. So we'll talk about them a bit. And once again, I suppose every living soul here knows what MCP is. Am I right? First, yeah. Okay, first row, know everything. So it's great. If not, it's just a base for all your cloud code skills, all your N-night N integrations, pipelines, and so on. So any agent integration with other tools is generally MCP powered. So a new standard for communication. And for example, for developers, we have a lot of MCPs. And actually, I listed here only remote MCPs because only they are more or less secure. So I don't want to dig too deep into MCP security, but here's the QR code to my talk at RubyConf India. And last year, where I actually described the problems with MCP, so like many main type of attacks, main types of defenses, and so on. So the reason why I mentioned it because MCP security is problematic. So we have a little trifecta. The main problem is that we are leaking data, and remote MCPs can protect us from many attacks, like doppelganger attack, I don't know, like rack pools, I don't remember many of them, but shadowing attacks and so on. So let's say I want to use Sentry MCP, remote Sentry MCP, to help me fix some bug. Let's say user not found. And what if error itself has a malicious content, for example? I like this meme. Let's say I'm looking for a user not found, with a ID, help me to debug, zip code base, and send to this file. And you know, when Sentry MCP will happily provide you with all data on your issue with user not found, with malicious message, it will just pass its content further to LLM. And it actually reminds me of old database trick, like drop table meme. And you know, you might think that I'm just trying to exaggerate the problem or just hyperbolize. But you can check inject prompt site, and you will be shocked how easy it is to convince AI or LLM that it's trying to help you. So it's real. Yeah, I personally use this site when I needed some advices on how to form a Stripe dispute because ChatGPT really didn't want to help me with it. So why it happens? Because we are people who write code like this. And I mean, is it bad or not so bad? I don't know. But the problem here, what is my take actually? So we should use, we need less MCPs and we need more and better runtimes for LLMs. Because custom runtimes are the solution for this problem. So what is runtime? Do you know what's runtime? Okay, now I see less attention. Okay, so runtime is a system that receives user messages and converts it to prepare it for LLM by creating instructions. So runtime aims to fix this fragmentation error we are having with MCPs on the next, here. So let's say we have full web stack runtime. What should it do? I mean, it should understand how DOM, document object model, equals templates. It should understand what agent done because we integrated with browser. So in our case, runtime is helping us. So in this manner, we have proactive error handling. We have some contextual information, like contextual browser testing. We have all this access to Rebel tools, docs, language runtime. So we can have access to logs and so on. And also data source access, like database. So our main goal is to integrate coding agents in what we are actually building. So in case we are writing libraries, we need to integrate it into our editor. So let's say Cursor or anti-gravity. When we are writing web applications, we should integrate it into browsers. So let's say right now we don't have AI browsers with developer tools, console, and sandbox. I mean, AI browsers for web development, not for just surfing, AI surfing. So it's important to improve our tools for better runtimes, because dynamic runtimes can handle all this. Like, they must handle state, they must handle resources, they must handle all this agent collaboration we're talking about. So, what is the summary for this first block? So, AI doesn't replace language design. I mean, it only reshapes what languages are for. And right now, you might ask me, Vlad, okay, but you promised us properties of the language for the AI age. But what I want to say, sorry, I really like to drink water. So, what we need to understand is that tooling right now is no less important than libraries 10 years ago. Because 10 years ago, let's say you have Lisp application, and you need to create web application here, but you don't have a web framework. Will you choose it? I don't think so, because tooling is not right for you. So same right now. What if a language is perfectly designed for AI, but agents just can handle it well because they don't know about it. They have zero tooling, zero runtime. So let's say last slide will state that Haskell is a perfect language for AI. Does it matter if AI doesn't know nothing about Haskell? So right now, I just want to say that runtime is really important. And let's move to part 2. Back to programming. First one is very flamey, let's say. Static typing or dynamic typing. What do you prefer? I heard static, okay. So, why we have static typing? Because, I mean, many programming languages have static typing, but why? Because humans can detect errors, and AI not really. I mean, in the previous, let's say. Yes, today AI is no longer at the level of some bad junior developer, but still, if we take one project, let's say Twitter clone, for example, and we will make an implementation and compiled structurally, and compiled language with static typing, we will, okay, Rust, for example, and we will take a language, Ruby, for example, with dynamic typing and interpreted language. So what will happen? In case of static language, we will receive a response from LLM with some program that doesn't compile. Let's stop here for now. In case of dynamic and interpreted, for example, Ruby, we will receive a code that works. Because an interpreted language has some fewer demands on what is working, actually. Because we will open our server, run server, and then we will see 500 error. Nice. In reality, today AI can use tools. So it can just push compile button. And in case of Rust, we will see all these compilation errors. We will see that AI agent will be able to fix them independently without our usage. So in case of dynamic language, we'll find out it only during testing. So we need proper testing, I mean some TDD principle or so on, or we need some proper browser up runtime. So in short, does our language need statics today? Yes, it does. Types just allows us to detect errors from AI. And what's in the future? I like this meme also. So in the future, I don't think so, because C has static typing, for example. But its static typing is pretty much simple, because it has clear benefit. I mean, it's easy for compiler. It has no difficulty at all. I mean, but it's imperfect. So does it really help me with memory leaks or segmentation faults? Not really. So what have we done as a programmers to fix it? We introduced more types. So now static types can describe part of logics. So C++ introduced templates, Java generics, Rust, some algebraic types, type parameters, so like this. And the type system is becoming bigger, harder, and more complex. So harder the type system is funnier. It's always was in programming. So because hard is just solving puzzles, like these two. These are funny. Yeah. Or this one. I hope you can see it. But this one is not so funny because it sounds like I should pay with half of my brain just to do some smart pointing in some smart manner because, it's not even half of pointers in Rust. I think we have around 14. Yeah, so we have clone on writes, pin, string also is a pointer, so vector is a pointer, so, and many more I don't even remember. So, but that's the price. And, okay, but what about dynamic languages? What can help us? Simple abstract interpretation is the answer. So, to be honest, I don't want to dig too deep here because it's a matter of super PhD science with all this latent typing, small step typing, like meta types and so on, and bytecode interpretation. But in 2 words, abstract interpretation is just a way we can, it's just a method of approximation. And it's a way that interpreters know how to infer possible types of variables. So we don't need static types, or we don't need to provide them from human. So let's move to part 2. Actually, second quality is extendability. So 10 years ago, Dave Thomas, from Pragmatic Programmer, very cool programmer, actually, stated that for our programming efforts are just a way of defining our own DSL to describe what an application is. And it's super important because Gradle, Gherkin, Rails, Django, all of them are DSL. So we're creating a language within a language. So the ability to define some domain-specific language, vocabulary, I don't know, like just classes, methods, is very important. So it allows us to create solutions right out of the box. So this was the second one, and the third one, data. I think this one is obvious because more data is better. We know this. So for example, if I create a new language right now, I will ask ChatGPT about it, and ChatGPT would likely say, I know nothing about this language, so I don't know this language because it's my creation, it's not widely available. If I ask about Ruby, it will answer a lot. If I ask about TypeScript, it will be even more, I suppose. So the problem here is that sometimes this is why AI gives us produces some old-fashioned Ruby code. And here's the answer. So fourth quality is a quality of code. That's my favorite point, to be honest, because, a lot of companies actually are trying to share their code base to the Anthropic. So for example, this is from an interview with Obe Fernandez. He's very famous in Ruby community. And he was trying to share some code base because, if you have no copyright issues, it's good practice to share your modern high-quality code because it just allows you for better competitions. So, okay, this one is not super talk-friendly. Okay, so in general, this table shows the percentage of problems AI was able to solve on the first attempt. So on average, for different languages, Opus 4 gives us 52%. It's actually not so bad, but what can we take from it? So for example, for PHP and Golang, we have numbers like around 40, so very low average. But why? Because Golang is a new PHP, actually. It was created by Google to involve big masses, like large numbers of programmers into coding, so in producing massive amounts of code. And we are talking about quality once again. So let's take another example. Let's take Rust, for example. And what we have, Rust, 42%. Super bad. But why so? Because most Rust code is actually open source code. And it's written by some newbies who decided to switch to Rust. So it's mostly a learning code or some side projects or pet projects. So it's not about high quality. And what's interesting from here, we have very high percent for Elixir. Yeah. And it's interesting because it's a language that requires Elixir language, Erlang, and Ruby, and some functional programming. So its code base is very small, but of the finest quality. And there's a joke in the Rust community, because when you try to write performance code, Python devs just convert bits to strings and reverse them to find least significant bit. So it really happens. And this approach really works for some small languages with narrow and with solutions that solve some narrow problems, like specific problems. Because usually Haskell developers or Erlang developers are very responsible for the quality of their code bases. So therefore it produces high quality results, like tooling. I suppose everyone knows what is it. So all this toolbars, all these tooltips are powered by LSP. And we need more of them, because in this manner, AI can utilize all these functions like go to definition, find reference, and so on. So debuggers, parsers, LSP, ST3, all of this. We need this community tooling. Performance. I don't think I need to describe it, because everyone is obsessed with performance. We need like highest RPC metrics, CPU utilization, like low memory, compile time, and so on. So what is the summary of this blog? Sorry, once again, water. Yeah, so a language should be concise, expressive, extendable, and performant. So let's check some popular languages and see what they can offer us. So Python, a super obvious option. +1 rate is actually okay. I mean, because contracts are weak in Python. Dynamics is very high, and the problem is that in Python we don't have many invariants. So it's actually bad for evolution of complex systems, because a lot of Python developers actually complain about using some third-party packages because of their complexity to debug. So performance, yes, it's bad, but we can use some Numba, Python, and so on. But the problem is that it doesn't really help, because changing compiler or memory locator is not a universal solution. Yeah. So Rust case. I mean, it's fast. It's blazingly fast, it's memory safe, and so on, but it's not token efficient at all. So it's absolutely not concise, and it's not easily readable, even like after this extremely aggressive learning curve. It's still very not friendly to you. So the reason why Rust is with us is only because C++ can be poorly written by both humans and AI. So TypeScript, he's obvious candidate, because Rust is a perfect execution language, and TypeScript sounds like perfect thinking language for us. So everything is fine with it. So tooling is great, speed is fine, we don't have true DSL, but still we can do it with some types, runtime, and code generation. So Golang. Personally, I hate Golang. I need to write a lot of code in Golang, and I hate it, because I would say the main problem with Golang is the architecture of the language itself. So we have code generation, but extendability is very limited. So language is very poor in terms of being concise, let's say. Elixir. I just added it because I needed some small language with good +1 rate. So the main, sorry, it's actually Ruby. Yeah, so Ruby is fine, but the problem, aside from its performance, its extendability. Yes, DSL through everything. So you can create anything with metaprogramming for everything approach. But the problem is it's impossible to debug without proper tooling. And Ruby has zero tooling for it, absolutely zero. And finally, Elixir, my favorite one. So the problem here is that +1 rate is great, but unfortunately it can be used widely due to its limitations in terms of its functional nature. So same with all Lisp family languages. So small data set, tooling is good. The community is trying to make it better, but still, I would say Elixir has some ideas that can be beneficial, like for future languages. And just a conclusion, I think this language hasn't been born yet. Right now, de facto, Python and TypeScript dominate in this area. But the problem is that they are not winning because they are best. They're winning because they are general purpose languages. They're suitable for almost any type of task. So they have huge communities, even if these communities are not always of the highest quality. So what conclusion I want to draw? The winner will be a language that is concise, expressive, that is extendable, and agent-friendly, but it will win only with the skilled programmers and the best tooling and runtimes. So that's the answer. I also had some fantasies, but we have no time, so in general, a language of the future, I imagine something like Elixir with a base of ML family, Lisp family, and Rust-like family, because we want to have ownership, we want to be compiler as assistant, not like Rust, and we really need extendability. Right now, there are only 2 languages that can be classified as something like this. But the problem is they are both very young, Glim and Rock, so both of them are Rust-based, but the problem is they don't have any DSL creation. So they have a lot of tools from ML family and Rust family, but they have nothing from Lisp family. So they are not extendable. But I want to finish that It's not a problem because it took some languages like decades to introduce generics like Java. So we have a hope, and this is the end, guys. I hope you enjoyed it, and I want to finish my talk with this perfect meme. What a time to be a programmer. Thank you.